Hi, welcome to today's webinar on the critical issue of inefficiency in relevant information discovery and its impact on companies and R&D's bottom lines. We'll explore how artificial intelligence can supercharge the R&D process, saving time and resources. In 2001, IDC's seminal white paper, The High Cost of Not Finding Information, revealed that knowledge workers spend 2.5 hours daily searching for information. Fast forward to 2018, given the increase in the corpus of information available, the situation seems to have only become more critical. The IDC study now found in 2018 that data professionals lose 50% of their weekly time, 30% searching, governing, and preparing for data, and 20% duplicating the work. Our extensive interviews with over top 100 industry researchers uncovered the same narrative. They described conventional information retrieval methods as overwhelming, frustrating, and even a nightmare. While they do believe that experience hones intuition, but a streamlined process for technical information discovery could save countless hours and substantial costs for companies. To understand this inefficiency in the traditional methods, let's look at the type of databases available and understand in that context. So, what does looking for information look like? If you're searching on a public database, Google excels at searching publicly available information, but it falls short for specialized R&D needs. Unless you're searching for images or maybe the cast of a movie, you're likely to face a list of documents to read and verify independently. The order of these documents further is based on the SEO or Google's website ranking that often leads to excessive noise and renders this method as too generic for focused R&D efforts. The example that you see on the screen right now is a search for clean cosmetic formulations, where a researcher's intent would have been to find out the exact formulations being used in sustainable and clean cosmetics, which is a very uh, recent uh, innovation in the cosmetics space. However, the results that we see are mostly product based and do not address the query directly. You'd have to sift through all this information to get to what you actually need, which is the formulation. This leads this method to be too generic. The second kind of databases, say the professional databases, consist of patents, peer-reviewed articles, and research papers. But accessing information on such platforms requires specific knowledge of that platform, specific querying syntax. They tend to have a number of filters, and you need to master the art of knowing how to use and when to use those filters to drill down to the exact information. An example on the screen here is from a database, a professional database, where again looking for the same information, we've been able to get some results, but with an absence of optimal querying and optimal syntax and filters, the results obtained are miss the actual context and do not address clean cosmetic formulations directly, but only certain fringe topics. Another example of public databases which are used by a lot of research professionals include Google Patents. Running the same query on it has led to results which are completely irrelevant in the absence of proper filters, in the absence of uh, proper querying language or proper syntax. This shows that there are four major problems when it comes to conventional information retrieval method. There is cognitive overload. There's a steep learning curve, especially with specialized databases. The process of information retrieval is slow, and wherever information is available, it could be presented in a complicated format. For example, patents. Patents which are written in a legally complicated language which makes it difficult to ascertain the technical or the scientific information present within. With the advent of AI, information discovery can be made efficient. Graebe's proprietary AI tool, Slate Pro, simplifies the process of technical discovery for R&D professionals. If we consider research process akin to an ocean, vast and daunting, then Slate Pro acts as a compass to relevant islands of information, making technical discovery easier and making your research voyage smooth and successful. Let's take a look at the tool. Welcome to Slate Pro, a tool for R&D professionals to discover solutions to research and innovation challenges. Let's start with the question that was demonstrated in the slides earlier, talking about clean sunscreen formulations. So, what are the formulations being used in clean sunscreens? On Slate Pro, you can ask a question in natural language without having to use any filters or any sort of syntax. It's as if you were asking your own research assistant. And here we have the results. We have a number of results to the query that we've asked. Let's read into them for more details. And let's see how much the context has been understood. The first one here talks about broad spectrum sunscreen compositions that provide high SPF protection without using organic sunscreen filters. So it's already talking about clean formulations. It consists of zinc oxide, titanium dioxide, amorphous silica, algae, film-forming polymers, and silicone compounds. The ingredients offer UV protection, water resistance, cosmetic benefits without visible whitening on all skin types, and the absence of organic sunscreen filters addresses concerns about health risks and stability. Additionally, there are SPF boosters such as styrene, acrylates, copolymers, salicylate, triethyl citrate to enhance sun protection. And there's also polyglycerine, there's also film-forming polymers, and uh, there is water resistance and a smooth application. So indeed, this is a clean sunscreen formulation as it avoids the use of organic sunscreen filters, and the point also goes on to talk about the composition in detail as has been asked. This is by LCS Advanced Solutions, and if I click on this, I will be directed to the actual source of this information, which in this case is a patent. The second one talks about a lotion with titanium dioxide, zinc oxide, avocado oil, sunflower oil, beeswax, coconut oil, cetyl esters, there's linoleate, and a few other compounds. It provides sunscreen protection and offers a natural alternative to conventional sunscreens, which have potentially harmful ingredients. And the testing results show efficacy, it meets FDA standards, and also has a broad spectrum protection. This one's by Pouch Pack Innovations LC. This way, we have a number of solutions here coming from all verified sources and all talking about the compositions of sunscreen. When we ran the same query on multiple other databases on, let's say, Google, we got more product-based answers. Running a similar query on Google Patents in the absence of actual filters led to very irrelevant results. And even with paid professional databases, the context was often missed. So now I'd like to demonstrate a few more examples here from various industries. This one happens to be from the cosmetic industry. Now, if we are to look into, let's say, the automotive industry, that's another industry where a lot of research is happening, especially with the shift to electric vehicles. So let's try and ask some question in that regard. As a researcher at an automotive industry going through shift to electric vehicle batteries, let's say I want to know how to improve the energy density of lithium ion batteries without increasing volume. So the question now has two parts: increasing the energy density of lithium ion battery. At the same time, the volume should not increase. Okay, so we have solutions. The first one here is about it addresses the query directly, increasing energy density without increasing volume by using a battery module that connects battery cells of different chemistries in series. It includes a first type battery cell with lower volume energy density but higher capacity, and a second type battery cell with a higher energy density but lower capacity. By balancing the capacity ratio between two types of cells, the overall energy is boosted while maintaining safety, and it also avoids stacking without excessive stacking, thereby not affecting the volume. Now, if we come to the second one here, it talks about improved energy density of lithium ion batteries, including an electrode plate at the outermost circle without an uncoated foil end, utilizing the space efficiently. The cell is wound with the electrode plate at the outermost circle, having an active layer facing the battery interior. The design reduces material consumption and enhances energy density. It also includes a glue, a separator, tabs for electrical connections, etc. More details can be read by clicking on this link. So, both the points that we've read talk about improving the energy density and at the same time address the second part of the query as well, which is not increasing the volume. We have a couple of other solutions that can be read into for more detail, and all of them addressing the same query. So, this was an example from the automotive industry. We can also look at another industry, say the food and beverages industry. In the food and beverages industry, researchers are constantly looking at alternatives to sugar, but one problem that arises is that a lot of those alternatives tend to have a lingering or off aftertaste. So let's ask something in that regard. What are the alternatives? What are the alternative sweeteners without an off aftertaste? So again, the query or the question has two parts. We're looking for alternative sweeteners that do not have an off aftertaste. So we have a couple of results. Um, the first one is about a sweetener composition that reduces the aftertaste and bitterness compared to traditional stevia extracts. It's a blend of stevia leaf extract, stevia oil glycosides, and fruit extract as well. It is low calorie, zero glycemic sweetener in foods and beverages. Then another one enhances sweetness, improves flavor and mouthfeel without off tastes. It has sucralose, masking agents, protein bounders, as well as mouthfeel modulators. And the protein shake made using the sweetener composition includes protein concentrate, soluble corn fiber, cocoa powder, and the composition has been described in detail. But all the points here talk about alternative sweeteners that do not have an off aftertaste. This is the use case of Slate Pro to find answers to technical questions, the kind of information which is difficult to retrieve through conventional methods. Hope this was helpful.